All right, here we have a top-down view of a 18-wheeler, and the 18-wheeler, the truck is driving to the east at 30 meters per second, and in the back of the truck, we've got a person running diagonally. They are running both to the west and to the north. The velocity is 5 meters per second, and the angle is 50 degrees north of west. When we say north of west, we mean you start out pointing west and you turn 50 degrees to the north. All right, so the question is, how fast is the man moving with respect to the ground? So we're going to use the basic formula that the velocity of the man with respect to the ground is equal to the velocity of the man with respect to the truck plus the velocity of the truck with respect to the ground. So in order to add two vectors, we need to put them both into Cartesian format with I and j. So the velocity of the truck with respect to the ground is easy. That is, well, we need a coordinate system. So we're going to choose a coordinate system where the x direction points to the east and the y direction points to the north. So if we do that, then the truck's velocity is the truck's velocity is 30 I hat plus 0 j hat meters per second. Because it's the x component is 30 meters per second and the y component is 0. To get the velocity of the man with respect to the truck, we have to find some components. So I'm going to redraw the triangle for that. We've got 5 meters per second is the hypotenuse, and this angle was given as 50 degrees, which means that, and right now I'm just going to treat this like a triangle. I'm not worried about any positives or negatives. So to find the base of the triangle, we're going to do 5 times the cosine of 50 degrees. And we get 3.21394 meters per second. And to get the height of the triangle, we're going to do 5 times sine of 50 degrees. And that's going to give us 3.83022 meters per second. Now, when I go to put this into I and j notation, I need to now be careful about signs, positives and negatives, because this is to the west, and so it's going to be a negative I hat. So this is going to be negative 3.21394 I hat plus 3.83022 j hat meters per second. And so to find the velocity of the man with respect to the ground, we add these together and we get to just add the components. So 30 minus 3.21394 gives us 26.7861 I hat, and then 0 plus 3.83022 gives us 3.83022 j hat meters per second. So if I want to leave this in I and j notation, I want to keep the right number of significant digits, which is 3. So this says that the velocity of the man with respect to the ground is 26.8 I hat plus 3.83022 3.83 j hat meters per second. And that would be the Cartesian. That would tell us the x and y components of the velocity. But if I want to know the polar, that is how fast is he moving and what direction, then I need to convert this into polar coordinates. So to help me with that, I'm going to redraw the triangle again. We know that the x component is positive 26.8, and the y component actually 26.7861. And the y component is 3.83022. So if I want to find how fast he's going, I need the hypotenuse, which is going to be the square root of a squared plus b squared, which gives me 27.0585 meters per second. And to find the angle, we're going to do the inverse tangent of opposite over adjacent. That's 3.83022 divided by 26.7861. And that gives me, my calculator's in radian modes, so let me quickly convert to degrees. That gives me 8.14 degrees. So the velocity of the man with respect to the ground is 27.1 meters per second at an angle of 8.14 degrees. So either one of these are a correct answer unless the problem specifically tells you to put it in polar coordinates. You can give either answer. I have another video on adding vectors in the math background chapter if you need some review on this.